All right, today we're going to be working on 2.9 multiplication and division properties. So to get started, we have this proof. You can go ahead and pause the video, try it out, and then we'll be going through it in just a second. All right, so looking at this proof, they give us that ST is congruent to SM, so these two blue segments are congruent to each other. You can start off with that. And they also tell us that segment TP is congruent to segment MN. So TP and MN are also congruent to each other. So we have those two sets of congruent segments. They want us to prove that SP is congruent to SN. So SP is the full segment here, this green segment, and SN is this other green segment on the other side, the full thing as well. So they want us to prove that those two green segments are congruent. Now, the first two are given statements. So ST and SM are congruent, and then the second two are also within our given statements, so TP is congruent to MN. Now, if that's the case, where we have TP and MN being congruent and ST and SM being congruent, well then, if I add congruent segment to congruent segment, the resulting segment is also going to be congruent. So the blue and the red combined with the blue and the red, so on either side, those will create these green segments for us. And since the blue and the red are both congruent to each other respectively, the green segments will also be congruent. So here's our proof. Our final statement would be SP is congruent to SN. And the reason for that is if congruent segments are added to congruent segments, the resulting segments are congruent. So again, we saw that in that last picture as well. So again, today we're covering 2.9 multiplication and division properties. Our learning target is I can apply the multiplication and division properties to solve problems and prove statements. So we're going to be doing quite a few proofs today. But these are going to be very specific proofs. They're very similar to our addition and subtraction properties, but there are some key words in here today that will help us in solving these. So let's go ahead and get started. In the figure below, points B, C, F, and G are trisection points. Now, if we recall what a trisection is splitting into three sections. So I take my segment, and these points are splitting my segment into three sections. So that means that AB is congruent to BC, which is congruent to CD. Also, on our other segment, EF is congruent to FG, which is congruent to GH. And I can show that they're congruent to each other here in making that distinction with two congruency tick marks. Now, if AB is equal to EF, which is equal to 3, so now all of a sudden AB and EF are the same. They both get one congruency tick mark now. And they're both equal to 3. What can we say about AD and EH? Well, if AB is 3, then BC will be 3, and CD will be 3. Likewise, if EF is 3, FG will be 3, and GH will be 3. So therefore, we can say that AD will be congruent to EH, which is equal to 9 units. And again, I got 9 because I just added 3 plus 3 plus 3. If AB is congruent to EF, is AD congruent to EH? Well, the answer to this is yes. Yes. And the reason why is both are trisected segments with one of the segments being congruent, meaning AB is congruent to EF. And if that's the case, then the rest of the segments would be congruent as well. So BC would be congruent to AB and CD, which would mean that the whole segment would be congruent to the whole segment if we see those trisection points. Now, you may be wondering, does this only work for segments? No. Like addition and subtraction properties, this will also work for any angles as well. So in the figure below, ray KO and ray PS are angle bisectors. If the measure of angle JKO is equal to the measure of NPS, and they're equal to 25 degrees, what can we say about angle JKM and angle NPR? Well, looking at this, if we have angle bisectors, we know a bisector cuts an angle into two sections. So each of these angles is being cut perfectly in two, so therefore they are congruent to each other as well. So all of these angles are 25 degrees. Oops, sorry about that. So we have all these 25-degree angles. So therefore I can say that angle JKM is congruent to angle NPR, which is equal to 50 degrees. If we look at this, JKM is the whole angle, and 25 plus 25 gives us 50. So similarly, if angle JKO is congruent to angle NPS, is angle JKM congruent to angle NPR? And just like on the last slide, we would say yes. Sorry, the bell was ringing. We would say yes. Both are bisected angles with one of the angles being congruent to the other. Therefore, the whole angle is congruent, just like the last one. So, yes. Both bisected angles, both are bisected angles. Go ahead and just fix that. Both are bisected angles with one of the angles being congruent to the other. With one of the angles being congruent to the other. Therefore, the whole segment is congruent. The whole angle is congruent. And that's our reasoning. If JKO is congruent to NPS, and they're both being bisected angles, the whole thing is being bisected, then the whole angles should be congruent as well. Now, this leads us to our theorems for today, and these theorems will be important, and I encourage you guys to leave a little bit of space underneath each of these theorems as you write them down. So, they're very, very similar to each other. The first one is the multiplication property theorem. It states, if segments or angles are congruent, their like multiples are congruent. That's the multiplication property. And on the next slide, I'm going to give you some tips on how to determine which one we're going to use, whether it be multiplication or division, which is why I want you to have a little bit of space here. The second theorem, if segments or angles are congruent, then their like divisions are congruent. So again, these are pretty much the same exact theorem. We're just changing the word multiples and divisions. Other than that, they're the same thing. So, tips on when to use the multiplication and division properties in our proofs. The first thing is we're going to look for the double use of the words midpoint, trisect, or bisect. And it's very important that it's used twice. I need to see at least two trisections, two midpoints, or two bisections in a problem in order to use either of these properties. If I don't see those words, I can't use these properties right away. Now, if I see these words, then I can go in and think, okay, am I going to use multiplication property or division property? Now, to use the multiplication property, it is used when segments or angles in the conclusion, meaning what we're trying to prove, this is what we're trying to prove in our actual theorems, when those segments or angles are bigger than the information that's given. So in my given information, if they're giving me smaller segments, so let's say I have this parallelogram here, let me draw it up real quick. And in this parallelogram, they say, hey, these two green points, these are midpoints. I'm like, okay, that means that I can use multiplication or division properties. And they say, okay, well, what we're going to give you is we're going to give you these purple angles, these purple segments. And we're going to say that these purple segments are congruent to each other. What we want you to prove is that this blue segment up top is congruent to this blue segment down below. So if we think about this, they gave me shorter segments. They're not as long in length. So I'm going from a small segment to a large segment. I'm trying to prove a large segment. So therefore, this would be the multiplication property. And likewise, if they give me the blue segments, they say, okay, these blue segments are congruent. We want you to prove that the purple segments are congruent. Well, then I'm going from big to small. And that's when I would use the division property, because it is used when segments or angles in our conclusion, what we're trying to prove, are smaller than what they give us in the given information. So if I'm going from a big segment to a small segment, it's division. And it's the same with numbers. If I'm going from a big number to a small number, I'd be dividing. If I'm going from a small number to a big number, I'd be multiplying. So it's the same exact concepts. So we're going to go ahead and take a minute and see what some of these proofs would look like. Now, you don't need to write down these proofs, but you definitely can. And these are things that you guys can go back and use as examples if you get stuck in your homework. So our first one is sample problem number 1. Given MP is congruent to NS, O is the midpoint of MP, R is the midpoint of NS, prove that MO is congruent to NR. So first things first, I see the word midpoint written twice. That means that we're going to use our multiplication or division property. Now, they give us that MP is congruent to NS, the whole segments here. And that means that we're starting large. We're starting with bigger segments. They want us to prove that MO is congruent to NR. So I'm going from the larger purple segments to the smaller blue segments. Now, if I'm starting large and getting smaller, we're going to use the division property. So, to start this proof, MP is congruent to NS, O is the midpoint of MP, and R is the midpoint of NS. That's all given. Those are my 3 reasons. So, from there, my 4th statement is going to be what we're trying to prove. So, MO is congruent to NR. And our reasoning for this, you can write the conditional statement as if segments are congruent, then their divisions are congruent. Or, much easier, you can just write by the division property. And that's what I'd prefer that you guys do. Write division property rather than the conditional for this. It'll save you a lot of time. So again, as soon as you see midpoint written twice, the proof should be pretty straightforward in just writing out your given information and then determining whether it's division property or multiplication property. But again, I can only do this if we see these words written twice: midpoint, trisect, or bisect. All right, here's sample problem number 2. Same type of thing. The first thing we look for is the word trisect, bisect, or midpoint written twice. And we see it written twice right here, trisect. From here, I look at my other given information. So they gave me angle TRY is congruent to angle ABE. So these 2 big purple angles that fill up all the other angles in there. So they give us large angles to begin with. What are they trying to have us prove? Well, angle TRW, this blue angle, is congruent to angle CBD, this blue angle. So, looking at these 2 blue angles, they are smaller than our original purple angle. So I'm going from big to small. So again, in this case, I would use division property. Same type of setup where the first 3 statements are all of our given information. The 4th statement is what we're trying to prove. Angle TRW is congruent to angle CBD, and that's by the division property. And that proof is finished. Here is our 3rd and final sample proof for today. We'll be doing one of these later on, so keep that in mind. So for this one, the first thing I look for is the word bisect, trisect, or midpoint written twice. But looking at it, I only see bisect written once. Now, at this point, I'm going to go ahead and read through that given statement. KG bisects segment MJ and segment FH. So it's bisecting 2 things, 2 different segments. So that's the same as writing it twice. I can say, oh, KG bisects MJ, and then KG bisects FH. So this is the same exact thing. It's already written twice, just once in a sentence. So keep in mind, you may have to be thinking, oh, am I only bisecting one thing, or is there multiple things? Now, from here, they tell us in our given information that MK is congruent to FG. So these are segments that only go to the midpoint. So we don't know if we're starting small or starting large yet. Let's go ahead and look at what we're trying to prove. We're trying to prove that MJ is congruent to FH. Now, looking at this, these blue segments, MJ and FH, they're much larger than our purple segments, MK and FG. So I'm starting small, going large, which means that we're using the multiplication property. So again, proof is the same setup. Our first two statements are given information. Then we say MJ is congruent to FH by the multiplication property. And that's the end of the proof. So these are how these multiplication and division properties, these proofs are all written. It's just the given information and deciding whether it's multiplication or division. And that's all based upon what they give you in the proof itself. So keep that in mind as you work through these problems. From here, we're going to go ahead and start solving some. So, use the given information to find the value of x. We're trying to solve for x. Go ahead and pause the video if you'd like and try this one out on your own, unless you get stuck, and then, of course, unpause it and see where you messed up. So, they start off by giving us angle HGJ is congruent to angle ONP. So those two red angles are congruent to each other. They also tell us that ray GJ and ray NP are angle bisectors, meaning they cut my angle, the full angle, into two equal parts, two sections. So therefore, angle GHJ is congruent to angle JGK. And if that's the case, angle ONP is congruent to angle PNR. So all of the angles shown up here, all these smaller angles, these are all congruent to each other. I know that angle HGK is equal to 50 degrees, so the whole thing is 50 degrees. And I know angle ONR is equal to 2x plus 10 degrees. So over here, the whole thing is equal to 2x plus 10. Now, is angle HGK congruent to angle ONR? Yes. They are congruent to each other. They're congruent to each other by the multiplication property. I'm starting small, I'm going large. I'm proving that they're congruent to each other because their bisection angles are congruent to each other. So from here, if that's the case, these two giant angles, these are congruent, well then I can say that 50 degrees is equal to 2x plus 10. From here, we get 2x equals 40. Therefore, x equals 20. And that's our answer. All right, go ahead and pause the video if you'd like and try out this next problem on your own, and then unpause it whenever you get stuck or whenever you finish. So for this one, we know that SW is congruent to SZ. So this purple segment here is congruent to this purple segment here. I know that lines TX and VY trisect SW and SZ. So if it's trisecting it, it's cutting it into three equal parts. So I'm cutting this purple segment into these three green equal parts. I know that ST is equal to 12. So ST will be 12. And I know that YZ is x minus 4. Now, if that's the case, each of these tiny green segments is congruent to each other. So therefore, I can say that 12 is congruent to x minus 4, or 12 is equal to x minus 4. Now, if 12 is equal to x minus 4, we can solve for x, and we'll end up with x equaling 16. So x is equal to 16 in the context of this problem. All right, next up, we have this proof here. So go ahead and pause the video, try this proof out on your own, and you can unpause it whenever you're ready to check. So looking at this, the first thing I do is I look for double use of the word midpoint, trisect, or bisect. And I see midpoint written twice. E is the midpoint of DF, H is the midpoint of GJ. From here, I look at the other given information. So they tell me that DF is congruent to GJ to get started. So DF is congruent to GJ. I can go ahead and draw those congruency marks on my segments. I know that E and H are midpoints. So I know that DE is congruent to EF and GH is congruent to HJ. What I now want to prove is that DE is congruent to GH. So looking at this, and again, DE is right here, GH is right here. Looking at this, I'm starting with larger blue segments, and I'm trying to work towards shorter purple segments. So I'm going from big to small. So if we write up our proof, we have statements, reasons, and our first couple statements will be what's given to us. So number 1, DF is congruent to GJ. That's given. And then also E is the midpoint of DF. And H is the midpoint of GJ. That's also given. Lastly, for number 3, we can say that DE is congruent to GH. And again, we're going from a large segment to a small segment. So is this division or multiplication? Well, this would be the division property. We're going from large to small. That would be the division property. And with that, this proof is now complete. Let's go ahead and bring it up, and here is our answer once again. All right, next, we're going to go into a little bit of review, make sure that we don't forget this information. So go ahead and pause the video if you'd like and try out this one on your own. If you get stuck, it's okay. Just go ahead and watch and figure out where you made your mistake. All right, so if 4 times the supplement of an angle, and when they say supplement, they mean 180 minus x, so 4 times the supplement of an angle is added to 8 times the angle's complement. So I'm adding this to 8 times the angle's complement, and when they say complement, they mean 90 minus x. So I'm adding 8 times the complement. The sum of that is equivalent to, meaning it's equal to, 3 straight angles. Well, how many degrees are in a straight angle? 180. We want to find the measure of the angle that is supplementary to the complement. So this is going to be a little bit of work, and this is probably the most difficult one that we've seen. The first thing that we do is we distribute through. We get 720 minus 4x plus 720 minus 8x equals 540. This will give me negative 12x plus 1,440 equals 540. Negative 12x equals negative 900. X is equal to 75. So we know that our original angle is 75 degrees. We want to find the measure of the angle that is supplementary to the complement. So I need to find the complement next. Well, the complement is just 90 minus x. So we have 90 minus 75. Well, 90 minus 75 will just give us 15 degrees. So that's our complement. Our complement is 15 degrees. We want to find the measure of the angle that is supplementary to 15 degrees. So to find that supplementary angle, that'd be 180 minus our complement. That'd be 180 minus 15, which will give us our final answer of 165 degrees. And that's it. Our final question for today is a factoring problem. I don't want you guys to forget factoring, so go ahead and solve for this trinomial. Pause the video if you need to, and then we'll work through it together. All right, so looking at this, it's already in the form of ax squared plus bx plus c equals 0. So it's already written in standard form. Now, at this point, I'm going to go ahead and take my a value, which is 1. I'm going to multiply it by my c value, which is 2. That will give me 2. At this point, I want numbers that add to be our middle term and multiply to be that multiplied term. So I need numbers that add to be 3 and multiply to be 2. Now there's a lot fewer numbers that multiply to be 2 than there are that add to be 3. So I'm just going to list out those numbers. We have 1 and 2. We have -1 and -2. Out of these two pairs, the only one that will add to be +3 is +1 and +2. So I now make my double bubble, just 2 sets of parentheses, and it's still set equal to 0, just like our original. The first thing that goes into both parentheses is the variable that we're working with. And that variable in this case is x. So I place an x in front. Next, I place the 2 terms that we found that add to be 3 and multiply to be 2. And those terms were +1 and +2. Now, if it has its own parentheses, it gets its own equation. So I have x plus 1 equals 0, and I also have x plus 2 equals 0. Solving for x, we get x equals -2, and we get x equals -1. So those are our 2 answers for x. If I plug in either of these answers in for x, we'll get the answer of 0. Now again, don't forget how to factor. It will be extremely important for you guys as you continue on in mathematics, especially for next year. Other than that, there is homework on Schoology, but we have now finished today's lesson, 2.9, multiplication and division properties. Again, our learning target was, I can apply multiplication and division properties to solve problems and prove statements. Thank you guys so much for watching today. If you have any questions, please let me know, but have a great rest of your day. I'll see you all later.